Welcome, everyone. My name is Nathan Heston, and I'm joined by my colleague here, Daniel Moyer. And the
Hello,
topic of
everyone.
today's training, good
Hello,
morning,
Nathan.
good afternoon, good evening, depending on where you are around the world. We're very excited to bring you this training. And this is a training entitled Whole Home Backup featuring the Sol-Ark 15k and SimpliPhi batteries. Couple orders of business here as we get started. We do have a Q&A feature, and if you have questions, we encourage you to interrupt, put those into the Q&A. Daniel will let me know when those questions pop up. He might answer some of those live by typing out the answers for you. So please make this interactive. We love the questions. Second, this is a NABCEP certified training. So if you're here for those continuing education credits, please stay through the end. We'll provide our email at the end, and we'll ask that you send us an email with your name as you'd like it to appear on the certificate. Then we'll get those continuing education certificates out to you by email. So welcome, everyone. One more time, Whole Home Backup featuring the Sol-Ark 15k and SimpliPhi batteries. So here's an overview of what we're going to get into in this training. We're going to go through some of the basics of battery energy storage, and then we'll talk about what we mean by whole home backup and how it compares to critical load backup, which is the more traditional feature of battery backup systems. They're most often used for critical loads and partial home backup. So we'll get into the differences there. We'll show you some examples of whole home backup, and then we'll talk about our SimpliPhi battery options, different options that pair well with the Sol-Ark 15Ks. We'll then get into the details and the features of the Sol-Ark 15K. We'll talk about sizing for whole home battery backup. That's important, not just capacity, but also sizing to account for the power needs of a Sol-Ark 15K or parallel 15Ks. We'll also talk about how to set up the inverter today, how to program in batteries, how to use the communicating feature of the Sol-Ark 15K if you have appropriately approved communicating batteries like ours. We'll talk about monitoring with both the Sol-Ark 15K app, and we'll also mention our Briggs & Stratton inverter as well and our monitoring options with that. We'll also talk then at the very end about our Elite IQ installer program if you're interested in installing this type of equipment for your customers. So who is Briggs & Stratton? Briggs & Stratton purchased SimpliPhi Power. Briggs & Stratton is a name you may well know, especially if you've used small engines. So I know the name Briggs & Stratton from my first go-kart. I know, Daniel, you often say that you first knew the name Briggs & Stratton from your lawnmower, right, when you were young. Briggs & Stratton's been around for 115 years. They've been a big player in generators, as you may know, but they also now are involved in batteries on two fronts. We have Vanguard batteries, which our factory is in the southeast of the US for producing Vanguard batteries. And those are typical systems that are used for powering things like golf carts and things like backup lighting systems for construction, rental equipment, etc. The SimpliPhi line of batteries has originated here in Oxnard, California. We've got a 15-year history, nearly a 15-year history producing lithium iron phosphate batteries. And we focus on battery backup systems for homes, offices, small businesses. So now we're one complete energy solutions provider doing both generators and home battery backup. We're one of the two companies that manufacture both in the US. I want to point out that Daniel and I will be leading trainings at the NABCEP conference next week. We'll also be launching a new product. Daniel, what are you going to be talking about next week in your trainings at NABCEP?
So I'm excited. My training is going to be focusing on off-grid living with SimpliPhi batteries. We're one of few companies that actually warranties our products for off-grid. I'm excited that I get to go first sessions on Tuesday morning at 9 a.m. Excited to talk about that. Please join us. And I know you might hint at this, but we're going to be launching a product. You already said that, but we're going to have an after party as well.
Yeah, we'll talk a little bit today about the new product we're going to be launching at NABCEP. We're going to have a party for you Wednesday night. I'll be talking about the same training I'm doing here, but I'm going to get into more details in terms of things like three-phase power, etc. when I give this training at NABCEP. I get an hour and a half at NABCEP to deliver this training. And so we're looking forward to that. If you're going to be there next week in Raleigh, North Carolina, then come join us. And if you are going to be there, let us know. We'll bring some swag for you, and we'd love to meet you in person. So we are launching a new product, and this new product is our newest battery. It's a stackable battery, and you can see it on your screen there. So there's some notable improvements for us. We've got increased power density in this newer battery. It's designed specifically to work with a Sol-Ark 15k. A single stack there can provide power for a whole 15k unit. We've got improved performance there. Nice streamlined design. That the stackable design means that your communications wiring, your power wiring, it's all done there through the stack connectors. And so we've got some new technology there we're calling rapid stack. We also have some improvements to our inverter as well, and we'll be talking about that. If you're interested in that, please do click the link or use the QR code in the bottom right to get that link if you want to get on the mailing list for these new products. So battery energy storage and why it makes sense. We're going to jump in here right into the topic because we've got a lot to cover. So first off, just the basics here. What is an energy storage system, an ESS? So an energy storage system on the right side of your screen, you can see an energy storage system. There are a lot of different details to it. You don't always have to have all of those. For instance, you can have an energy storage system without solar, without a generator. But of course, you do need batteries and an inverter. Those are the two main things that we're going to be getting into today. Of course, you can have an energy storage system off-grid as well, in which case you wouldn't have the grid. So at the heart of an energy storage system is a high-quality inverter. Right. And what the inverter does is it processes and controls the energy flow to and from different sources and provides that energy to the home. So you need a high quality inverter that's capable of multiple inputs. The Sol-Ark 15k is an example of a hybrid inverter. It contains MPPTs for taking in solar power, and it contains charge controllers for charging the batteries, as well as transfer switches to switch between the loads to isolate in the case of a grid down event so that we're not electrifying the lines when the grid goes down, but we maintain continuous access of power to the home. And then, of course, for an energy storage system, at the core, you need a high capacity battery that's able to not only provide a certain amount of backup time through an energy capacity, but also a power capacity capable of delivering enough power to the inverter to run those loads in the home.
Nathan, we already have a question. If you could go back
Great.
to that slide, I think this
Sure.
slide is going to help us answer this question, and it's a good one. Russ is asking, and please thank you for the question and keep them coming. What is the best method on a grid-tied system to connect AC coupled solar and a generator to the Sol-Ark 15k? I think in this diagram, we're assuming that this solar picture is DC solar. So Nathan, if you could please address that question.
Yeah, I think it's a great question. And Russ, if you don't mind, I'm actually going to postpone until we get to one of these diagrams. But I think the answer is probably going to be in an interlocking breaker, potentially an automatic transfer switch. But the problem with an automatic transfer switch, we'll talk about in a little bit, is that you would need to reprogram that inverter. So let's postpone and let's hit that again when we get to a slide where we've got the wiring diagram, so we can make sure that everybody follows exactly what Russ is asking, because we've got one generator or one smart loads input on the Sol-Ark 15k. And of course, if we are on a grid-tied system, then we're already using that grid port, which we could utilize in an off-grid situation for the generator. So let's jump into that later. It's a great question, Russ, and I'll come back to it. Let's look here briefly at the parallels between generators, which are the more common backup system from days ago, but are still a popular option for backup power. And there are a lot of benefits to generators compared to batteries and inverters still. But let's talk about the parallels between them. So often the parallel is made that the storage tank, the propane tank, or your propane supply from your municipality, right, is analogous to the battery. And your generator is analogous to that generator is analogous to the inverter. That engine that generates that electrical power is similar to what that Sol-Ark inverter is doing. But the parallel breaks down. I mean, both of these systems can give you energy independence. It can give you backup in the case of a grid outage. Both of them can give you peace of mind, knowing that you're going to have electricity when you need it, just because a fire comes by or a flood or even a tree down, which was very common for me growing up in the Northeast. You're still going to have power in those situations. And with many of us working from home, having home offices, even in home shops, those kind of things, we want to have access to that power. So we've got that business continuity. Of course, there are people that need critical appliances and medical equipment in their homes. Both options give you that. But what's different, what's kind of an advantage for the battery systems is that you can now do energy arbitrage, right? You can buy electricity from the grid when it's cheap, right? And use that energy when you need it, or sell back to the grid if you're generating from a renewable source when it's advantageous to do that. Now, Daniel gives a great training on NEM 3.0 and how some of this has changed with incentives for feeding back. And so we can get into that, but there's that ability to do that, buy low and use when it's expensive. You can do peak demand management, and the Sol-Ark 15k is great at this. You can limit the amount of power that you're pulling from the grid. You can use some CTs, monitor what you're pulling from the grid, and be exporting that back to your panel so that essentially it zeroes out your meter. You're not pulling anything from the meter. You can also take advantage. There are a lot of government incentives out there for having backup power in homes and having solar, right? Having green and renewable sources. And these are there because the grid needs that help, right? The grid is in many cases is struggling with this increased demand, and utilities want us to have backup power. Maximizing solar energy production and self-consumption, we can do that if we have batteries. We can do time of use savings, in which we buy or we create that energy and then we save it and deliver it to our loads when we need it. Time of use involves higher charges from the utilities at certain times of the day. For me, peak times are evening time, right? When that sun is now low in the sky, but everybody comes home from work and turns their devices on. And then, of course, there are the benefits of using renewable system for environmental conscious consumers. What do we mean by whole home backup? So I've got a slide here, and this slide is going to show us what happens in a grid down situation. So if you look, both of these are grid tied systems. Both of them have batteries. Both of them have an inverter. On the left side of the screen is a Briggs & Stratton inverter, and this inverter is a smaller inverter. It's 6 kilowatts maximum output. It also requires the installation of what's called a critical loads panel or a backed up loads panel. These are loads that when the grid goes down, you still want to maintain access to. You might not need to have the washer and dryer. You might not need to have everything in your home on backup, but you'll probably put your lighting in there. You'll probably put your internet connection on there, possibly your television and other things that you want to keep on during an outage. But notice the difference on the right side of the screen. On the right side of the screen, the main loads panel is the only loads panel that's there. And so the right side is that whole home backup option, right? It's backing up all the loads in your house. So let's look at what happens when the grid goes down. And when the grid goes down, the main panel has no electricity in it. And the Briggs & Stratton inverter will isolate itself from the main panel so that it's not pumping energy back into the main panel and potentially hurting somebody who's working on the lines. But notice that battery power is going to be coming into the inverter and your critical loads stay backed up. That does mean that all those loads in the main panel, though, are no longer backed up. On the right side of the screen, if the grid goes down, the entire loads panel stays on. The Sol-Ark is now isolated from that grid. The grid is no longer there, but we're still backing up all the loads in the house, and we do that by having a single loads panel. Note also the differences in the installations here. On the left side of the screen, we would have to install an additional panel and potentially move some loads over if we're backing up a home that currently doesn't have a critical loads panel, right? So here are a couple of other examples. We can see these come from installers that have been posting these on the internet, and so we thank them, and I note their names here. If you do some of these installs, feel free to send us pictures if you would like to include yours here. So on the left side of the screen, we're actually looking at it looks like a 12K there, Sol-Ark, and we're looking at on the top left, there's a DC combiner. And then we've got a critical loads panel here, not a whole home. You can also see AC coupled solar coming in from that install. On the right side of the screen, we're looking at one of our Boss 12 cabinets. There's 45 kilowatt hours of energy storage there. And that's running to a Sol-Ark 15K. And you can also see a smart loads panel, the span panel there as well. So let's talk just briefly, and Daniel, I'll take a time here for some questions. Do we have any questions in the Q&A?
We do a couple ones. One is Harvey Bell is asking, will the new battery be backward compatible with the system of 3.8 SimpliPhi batteries? And I'm not sure if we mean, can we combine the battery banks? So let's run through some of those scenarios.
Yeah, I think that is what he means, and the answer, unfortunately, is no. We cannot combine the new battery because it has different internal resistances. It has different charging parameters, and so we can't have a combination of the 3.8 batteries or really just batteries of different format. We have to stick with the battery we have for banks.
And yep, thank you. And Harvey actually mentioned he is doing a Sol-Ark 15K with 45 kilowatt hours of SimpliPhi batteries as we speak. So thank you, Harvey.
Cool. Yeah, it's a popular storage option, and the Boss 12 cabinets are a nice way to be able to go outdoors. So I'm not going to spend a lot of time on this slide. I just want to point out that historically everything, with the exception of off-grid, right, was critical loads since about 2001 when hybrid inverters came out and we had this ability to not backfeed the grid. That meant that these grid tied inverters were running critical loads panels simply because the capacity wasn't there, right? On the left side, we're looking at some Tesla Powerwalls. Their initial output capacities are quite small, right? 3.3 kilowatts for the Powerwall 1. 5 kilowatts for the Powerwall 2. We've got a trace inverter there, the Schneider SCP, the Schneider, Daniel, help me out on that one. 6048, 60, I believe it's 60.
Yeah, I think it's the context and maybe yes, a storage there as well.
Solar Edge is here as well. Our 6 kilowatt Briggs inverter, all of these require critical loads panels, even the Sol-Ark 8K, the Sol-Ark 12K, right? With the capacity is just not there to back up the whole home. The true advantage of the Sol-Ark 15K here has to do with that 200 amps of pass through. We can pass 200 amps from the grid through the Sol-Ark 15K and back up the entire loads panel. Now, that doesn't mean that the Sol-Ark 15K is capable of 200 amps of 240 volt AC service, right? You certainly can overpower the 15K or cause too much of a demand on it so that it overpowers. But we now have the ability to provide for most panels in the US with that 200 amps of pass through, which means we don't need a separate panel. So battery limitations come in here as well. People often think of the battery, but don't think of how long it's going. Think of how long it's going to last in an outage, but they don't think about the power limitations. Remember, we have to have enough DC current running into the inverter to be able to power those loads as well. So we're looking at that 45.6 kilowatt hour Boss 12 cabinet there is capable of 22.8 kilowatts of continuous output power. You're also looking at a 19.8 kilowatt, a newer SimpliPhi 6.6 stack. So you got 20 kilowatt hours of storage there. And that one can produce somewhere around 14 kilowatts of power outage. I believe we're still finalizing the specs on that. The 6.6 batteries have a high output power that's greater than C over 2. Talk just briefly about loads here. Most of you are quite familiar with loads, but not all loads are the same, right? We can have soft starts on air conditioners, etc., which will play a little bit nicer with inverters than those extra start coils do. On the top left of the screen, there's an example of a heat pump water heater, and these heat pump water heaters for 1 unit of electricity, you can deliver 3-4 units of heat depending on your location. They also give an added benefit of they essentially are acting exactly like a dehumidifier would. So if you have that garage shop and you want to keep your tools from rusting, having this in your shop is also a nice feature. And that's a great advantage over electric water heaters, in which you're really just getting a 1-for-1 exchange. You use 1 kilowatt of energy and you get 1 kilowatt of heat. So that's a common feature. A lot of people putting in these mini splits as well, and we're looking at adding these loads up as the customer is using that battery backup in the home. Of course, electric ovens can be a real drain on power as well. A big demand, but something that you probably want to have backed up in a grid outage. You want to be able to cook. Furnaces are on there. Yes, I know they're gas, but they also have those blower motors, and those blower motors to move the air around the house typically require a decent amount of power. So when you're educating your customers on the use of their backup system, their solar, their batteries, their inverter, it's worth pointing out to them the different devices that can cause overloads and the different devices that, when being used, are really demanding. So I wanted to show what it would look like if we wanted to parallel a couple of 6 kilowatt inverters. We're still going to need a critical load backup. And so what I'm showing here is just a simple single line diagram for what critical load backup would look like. This is a partial home backup. We're not backing everything up. Our inverters are parallel. We can put up to 4 of these units in parallel to get more power output. You're looking at a rapid shutdown devices there on the left on the solar panels, a disconnect, of course, and then a fused disconnect on the bottom for the batteries. For a Sol-Ark 15k, here's a nice simple example of an easy install. I'm showing it with a new stack of 6.6s there on the left, where you have 20 kilowatt hours of storage. Looking at how we're wiring this, though, we're coming in from the main meter. We're going through a service disconnect. And this should be fused or breakered with an appropriate disconnect at 200 amps. And so we can pass that 200 amps through the utility port of the inverter and then out to the loads. And then the inverter itself will supplement the power of the loads with utility power if it's needed, if the battery is low or if there's not enough solar coming in. Of course, typically you would be sizing that solar to come in to cover the loads and provide some extra power. So generally you'd be able to charge the batteries, but you can do this with small systems. Small solar, the battery system, of course, has to have enough power to be able to power the inverter. I also want to point out that you can have AC or DC coupled solar with this Sol-Ark, and you could have both. You could have up to 19 kilowatts of AC coupled solar and simultaneously have 19 kilowatts of DC coupled solar, although Sol-Ark recommends that you reduce the amount of AC coupled solar compared to DC coupled.
No, Nathan, I'm noticing, I think we're actually showing AP Smart Rapid Shutdown devices up here on the top left. I believe Sol-Ark now does have SunSpec rapid shutdown capabilities built into the inverter as well. So does our SimpliPhi 6K inverter. And now Sol-Ark rapid shutdown modules, I believe they're coming out with optimizers. They haven't hit the market yet, but they are coming, and I'm excited about that because not only do you get optimization, but also rapid shutdown capabilities. Carl is asking, he has a question. Is there a higher pass-through solution in the works? We are seeing more 400 amp service installations, and my electrician recently did a 600 amp service. And there's an exclamation point there as well.
I can't speak to what is on the horizon yet. I can say you can easily parallel 2 Sol-Ark 15Ks to cover those larger amounts of pass-through. And if you're really looking at backing up 400 amps worth of service and those 400 amps are justified, then I would recommend more than one Sol-Ark inverter, right? Each inverter is capable of 12 kilowatts of output power from the loads, which, if I do my math correctly, I believe is about 60 amps on the AC side of things. So if you're really trying to back up 400 amp service, I would recommend using parallel 12K or 15K Sol-Arks. You can parallel up to 12 of these inverters to cover that. Not sure if I have a slide on it, but we'll get to it towards a little bit later on in the talk. I'm going to run through these fairly quickly. I do want to come back to Russ's question because I think it's an excellent question. Here is a grid tied, here is an off-grid inverter, and we are bringing a 26K Briggs & Stratton generator in through the grid connection, which is what Sol-Ark recommends you do for an off-grid system. So I'm looking here at a 26K generator. We've got a bigger battery bank here than the 20 kilowatt hour battery bank I showed on the last slide, because typically off-grid customers need a little bit a larger battery bank to get them through those longer outages with maybe solar not producing as much on those cloudy days, etc. But what we're looking at here is just a single panel, and this would be the same whether this is a Sol-Ark 15K or even just a smaller Briggs 6K inverter. But the advantage you have here is you can bring a 22K generator in through that 200 amp grid connection. You can bring a 26K generator in. And so Daniel's going to be doing a whole training on that at NABCEP. Daniel, do you want to talk a little bit about your training and continuous use generators for off-grid cases?
Yeah, absolutely. I think kind of what I want to sum up in my talk is that with the advent of these hybrid inverters and batteries, specifically lithium-ion chemistry batteries, we can really build some very elaborate, very nice off-grid homes where you don't necessarily have to sacrifice a lot of the luxuries that you would see in grid-tied now for off-grid homes. So it's exciting, and please come visit us in NABCEP.
Thanks, Daniel. And let me jump to Russ's question. So I don't have a generator shown on the screen here. We have one generator port in the Sol-Ark. It's actually a smart loads port / generator port that we could either bring AC coupled solar in through or a generator through. If you want to do both, the challenge, of course, is in programming the Sol-Ark to know what you've got coming in, so you're categorizing it correctly in the monitoring app, etc. So I think that, you know, in doing this, you have a couple of options for your AC coupled solar. My first suggestion would be to leave. I think I'm not exactly certain here whether we could leave the AC coupled solar in the main loads panel, and it depends on how big it is, I believe, as well. So you can AC couple through loads port. The challenge with that, and one of the things that Dylan has said in some of his trainings is that you don't then have any visibility in your monitoring app as what you can see if you bring in AC coupled solar on the load side. So you can do it, but then you don't get the monitoring advantage. But that would still leave your generator port open for you to be able to get that generator to work and be able to use the 2-wire start. If you want to use the generator port for AC coupled solar and a generator, then you would have to do a manual transfer switch if you want the 2-wire start to work. So I hope I've answered your question, Russ. It is a little bit more complicated. Daniel, any more questions?
Well, Mike had mentioned, can the grid input be used for both generator and grid via a transfer switch of some kind? And I think that would, and you can expand on this, that it's going to need to be reprogrammed. And just so we're clear,
and I think the answer is no there, right? Because we, well, I'm not certain of that. So I think we'd have to defer to Sol-Ark's technical support there.
And just so we're clear, we're not saying that you can't AC couple solar into the generator port. I think that the discussion here that we're trying to talk about is that if you have both a generator and a AC coupled solar, and you have grid and you have load, how do you use two inputs into one input port on the system?
With use of the 2-wire start, so that the Sol-Ark automatically starts the generator when it needs it. I mean, that's the added complication for me. When I program the smart loads port to say I've got a generator there, that's what's automatically starting the generator when the batteries get low, or so if the grid goes down, we're going to use the batteries first. We don't want to start up that generator and use that more expensive fuel. And so keeping the two-wire start functionality of the inverter to control that generator is where I'm experiencing more of that challenge. And that's why I was suggesting that I would do it through the loads port. If you brought your generator in through the grid port, there are other complications as well in switching between it. So I do think that you could do that, but then you lose the two-wire start functionality, I believe, of the generator by using.
But if it was
that transfer switch,
if it was off grid, that would be no problem because there is
off grid,
no
no problem. Which is why I kind of jumped to your other slide. Let me talk just for a minute on our batteries. We are using lithium iron phosphate batteries. We've been doing this for 15 years, right? We've been doing this since 2010, 14 years. And we've been perfecting our lithium iron phosphate batteries, our BMS, our essentially our ability to make these systems last longer and longer and longer. We have a very solid warranty. We expect 10,000 cycles out of these batteries. That SimpliPhi battery that's on the screen there has a 15-year unlimited number of cycle warranty. We still allow 100% depth of discharge. We recommend 80% because at 100% depth of discharge, we're looking at 3,500 cycles on the battery. But with 80% depth of discharge, we're expecting 10,000 cycles. So you do get a big jump there. If you do a 90% depth of discharge, it's more like 6,000 cycles. And we still expect an end-of-life capacity of 70%. I don't think that there's any company out there that can offer better expectations for life cycle of their batteries and back it up with a warranty from a company is going to be around. We've been around for 115 years. Briggs & Stratton will be there to back up their warranty. Also want to point out, if you are a California installer, we do have, as a California recognized battery manufacturer, you can get an extra 20% discount off this self-generation incentive program. And so keep that in mind if you're a California installer. I know many of you are across the country. Just talk a little bit about our battery lineup. Daniel, feel free to interrupt me with questions. But what we're looking at here on the left side of the screen is a Phi battery. That Phi battery is a non-communicating battery, so you don't have the advantages of the easy setup where the inverter auto-populates your settings. It also doesn't give you quite as much information, but the Sol-Ark has fairly good monitoring of these batteries, and sometimes less is more. These Phi batteries are very popular for big installs, and I'll show you some examples of those here in a minute. The SimpliPhi battery is a very popular choice. It's got communications. It's an indoor rated battery, just like the Phi. You can't put it out in the rain. But it's got closed loop communications there, and you can get a lot of detail, especially with our monitoring system, the Energy Track monitoring system, about individual batteries, their performance, if there are any issues, temperature, that kind of thing. We additionally have the 4.98 kilowatt hour battery that's on the screen there. You can parallel up to 60 of the SimpliPhi or the 5 kilowatt hour SimpliPhi batteries. This is really the limitation there is with the closed loop communications, right? If we get too many of them, we'll have too much loss of voltage in those communicating wires. So we can do about 60 of those batteries. That's our limitation. 300 kilowatt hours of storage, that's huge, right? Single Powerwall's 13. We're looking at 300 kilowatts of storage here. And then on the right side of the screen is our newer battery. We haven't released the final specs yet. The engineering team is still finalizing and going through the details of that. We'll be launching that battery next week. And so if you're interested, you can get it there. That is a 20 kilowatt hour stack, three of the 6.65 units. Both the two batteries on the right side of the screen are outdoor rated. Now, that does not mean if you're in North Dakota, just because they have an outdoor rating, you can stick them out in the cold. Lithium batteries, lithium iron phosphate batteries in particular, right? They need to be kept at appropriate temperatures. And that temperature range on the battery on the right is a little bit greater for charging. We've improved the electrolyte that's used there. But again, you need to pay attention to the temperature. So if you are doing an outdoor install, you're in a temperate climate like we are here in California or the south of the United States, and you want to do an outdoor install, you could also consider using these BOSS 6 and BOSS 12 enclosures. These are 9540 certified, 9548 tested. You can parallel, go all the way up to 136.8 kilowatt hours there. Very large systems if you want to parallel these. They've got built-in fans that turn on when the temperature is above a certain range, and these are helpful for outdoor installs. Let's jump into the specs of the Sol-Ark 15k. So Sol-Ark 15k, effortless communications with our Briggs & Stratton batteries. In fact, our batteries are designed and released with software that goes through the test with Sol-Arks prior to release. So we specifically design our batteries to communicate with Sol-Arks, and we have a healthy collaboration with the Sol-Ark team, which you might notice if you've seen us at the trade shows, right? They're featuring our new batteries in their booth. We were there at Distributech with them. This is a great inverter. I love the Sol-Ark 15K. It's got an indoor-outdoor construction, so you can mount this outside. It's an IP65 rating, NEMA 3R enclosure. Everything on this is stainless steel in terms of the hardware. The mounting bracket is got stainless steel fasteners that come with it. So this is an outdoor-rated inverter as well. You've got 12 kilowatt battery to load. So this means that you can pull 12 kilowatt out of batteries and put that directly to loads if you're at a time of day when you don't have solar, or if you install it without solar. If solar is available, you can output 15 kilowatts and simultaneously charge your batteries. You've got 24 kilowatts, 10 surge capacity. So if you need to start up some big loads, you can get up to 24 kilowatts for 10 seconds. You've got 19 kilowatts of DC input on solar, 3 different MPPTs, right? Which means that you can have different facing arrays, one facing east, one facing south, one facing west if you want. You can also do an additional 19.2 kilowatts through the Gen port or the Smart Loads port, which was what we were talking about earlier. And this big feature of 200 amp AC pass-through, so I can bring in 200 amps from the grid. There's a mistyping here. Sorry about this typo. It is an 80 amp generator port. I believe initially it was intended to be 100 amp, and it's scaled back just a little bit to 19.2 kilowatts, which is 80 amps. Automatic 2-wire start of our generators. So the 2-wire start on the Briggs & Stratton generators pairs directly with these Sol-Arks. So you've got that power to start up your generator right in the control of the inverter. It will only use that generator if it needs to, uses the cheaper electricity first. Parallel up to 12 of these units. And of course, we've got a long history of success with Sol-Ark. So let's talk a little bit about sizing. We'll get into more details here. I just want to point out that it's important to size your batteries to the power of your inverter. We all know about the energy capacity of the batteries and how long those batteries will last, and working with the customers to size their battery system to their needs. But we also have to size to the needs of the inverter in a high power situation, right? So the Sol-Ark 15K can pull 12 kilowatts from the batteries. If you have non-communicating batteries, you need to make sure that you're programming in the power output ability of your batteries into the inverter. And you do that by programming in the maximum current. So with our Phi batteries, which are non-communicating indoor batteries, we recommend that you have a minimum of 8 of these batteries for a single Sol-Ark 15K. That's to cover 12 kilowatts of loads. Now, you can go lower, but you need to make sure that you program appropriately. So at full capacity, 15 batteries would cover 2 paralleled Sol-Arks, and 22 batteries would be enough to do 3 paralleled Sol-Arks, 36K of continuous output on 825 amps DC. On the SimpliPhis and the SimpliPhi batteries, they have closed loop communications. You can do less than the recommended number of batteries. You'll get a shorter runtime. However, you will also get less total power output than that 12 kilowatts from batteries that the inverter will deliver. And that will happen automatically. So there were a lot of questions in a previous version of this webinar where people were asking, can I go less than recommended? The answer is yes. But if you go less than recommended, your continuous power output will dip. You can still surge, but you'll have a shorter amount of backup time, and your continuous power will be limited. And then on the right side of the screen, just a single one of 3 of these stackable batteries, a single stack here with the controller will power a Sol-Ark 15k continuously for that full 12 kilowatts of output. I mentioned paralleling inverters. There are a couple of pictures here. The first one on the left there is I think an off-grid install in the village of Eagle Creek, Alaska by Wolf Solar. And I've got the link there on that if you want to see some of their installs. They've done some really nice installs. These are split phase 240 systems. And so they've got 7 inverters there, and they're using the Phi batteries with customized bus bars to accomplish the power needs of that village. On the right side of the screen, we've got an install in Connecticut done by AEGIS, and they've got 7 inverters in parallel there running Phi batteries as well. So I mentioned that those Phi batteries are a popular choice for large parallel systems. Let's talk about wiring, how we wire, what the inside of a Sol-Ark 15k looks like. So I'm going to start from the left and go to the right. Daniel, let me know if we've got any questions coming in. So what the Sol-Ark 15k connections look like when you open up this inverter. On the left side of the screen, we've got the battery inputs. So you've got 2 independent breakers for your battery inputs, and they've done that so that you can run 2-aught wiring instead of being required to run 4-aught wiring. So if you have 2 individual leads coming from 2 battery banks, you can combine them at the inverter and run them through 2 2-aught connections. If, however, you would like to run just a single bank with a 4-aught connection, you can buy these bus bars that are made specifically for the Sol-Ark 15k and combine those connections so that you have one 4-aught connection coming in and you're not limited by a single 200 amp breaker. Again, continuous input from DC side on the Sol-Ark 15k is 275 amps continuous. The breakers are oversized there so that you can surge, not for continuous. In the center of the screen, this is where the communications is. The paralleling communicating RJ45 connections are shown there with a circle. And so if you have multiple inverters, you're going to daisy chain them. One's an input, one's an output, and this runs in a big loop. So if you had 2 inverters paralleled, you'd fill both of those spots with Ethernet cable to run between them. The battery CAN bus is on the right side of the control board there. That is going to run into your battery bank. You only need 1 for your battery loop, the CAN bus connection there to the inverter. On the bottom with the orange connections there, of course, that's your 3 different MPPTs. Notice that there are 2 sets of MPPT per, 2 sets of connections for each MPPT. So you can land, you can do 2 parallel strings per MPPT. On the center of this screen there, where you've got the generator and that smart load input that we've been talking about. You can bring 80 amps of 240 volts there. That's either 19 kilowatts through from a generator or up to 19 kilowatts from AC coupled solar as well. You do need to set those settings appropriately when you bring that power in, and I'll talk about that in a little
smart
bit.
Load output. Smart
load output, yes. Hopefully I didn't mix up my words, but thank you, Daniel. And then, of course, on the bottom of our inverter, we've got our neutral bar and then our grounding bar. Keep in mind that that neutral ground bond is going to come in at the service disconnect. So we do separate the neutral and the grounding bar here in the inverter. The loads port here is shown, and you've got a breaker there to shut off your main loads panel. And on the right side of the screen, of course, that's your grid input, your your L1 and your L2 for split phase. These inverters, of course, can do 3-phase as well. So if you've got a 3-phase Y configuration, you can do 208. If you've got a 3-phase delta, we need to run through a transformer, but we can do that as well. So I'll talk about that a little bit later if there are questions. So coming back to our wiring diagrams, now that we've seen all those connections, this is what it looks like when we're putting our system together. And I've got this here in case you want to run back through with questions. But the communications port, like I said, you're running 1 wire from your communicating battery over to that inverter. And then if you've got a single home run of 4-aught, you might want to use those combiner bars. Another example here, I am showing ways to combine power using these power distribution blocks, and I highly recommend these. These are a really nice way to parallel your connections. So if you want to join your L1 and L2, go into your loads panel, etc., you can use these parallel, or sorry, you can use these power distribution blocks within your wiring gutter, or your wiring the trough there to do that, your wireway. So mounting the inverter. The inverter is about 130 pounds. It mounts fairly easily though. And the way you mount it is there's a bracket that you put on the wall behind the inverter, and then you simply lift the inverter up, or two people can lift the inverter up and hang it on that mounting rack, and then you can secure it through on the top with the screws to secure it. I recommend installing this with a wireway. A 12 by 12 wireway will get you all the way out. You can squeeze by with a 10 by 10 wireway. And the nice thing about that wireway is it just gives a nice clean look, and it makes it easy to run your wire, gives you some room as well. So I mentioned before using these power distribution blocks to do combining. If you need to combine, you can get these in very large, 500 amp blocks if you're wanting to use these as combiners for batteries as well. On spacing, you need 6 inches above and below the inverter, and that's for the fans to be able to run the cooling through the back. The inverter needs 2 inches on either side unless you're paralleling units, and then you actually need 6 inches between inverter units per Sol-Ark's spec. The top right of your screen, when you're doing your knockouts, if you're looking for a template, you can get one of these. These templates make it nice, easy to get your punch throughs done on your wireway, and so these are available. I thought I'd show you there, and I believe there's a link for you if you need that. Wiring the communication loops. So closed loop communications with batteries. We have 3 different ports on our batteries. So I'm showing on the left, this is an SimpliPhi battery. One of them is a device port. The other are for daisy chaining the closed loop communications on the batteries. So that one that looks a little bit different is actually labeled device on the battery. That one goes to the inverter, and you only need one battery wired from the device port to the inverter. If you have the last battery on the chain I'm showing here, you do need to make sure that you don't have any open ports. So the last battery on the chain, you do need to have a terminating resistor. And so I'm showing these resistors on those last batteries. And then of course that one connection from this diagram here would go into that CAN bus port on the inverter. If you're doing rapid shutdown and 2-wire starts, rapid shutdown you need to have, if you have a rooftop solar array, that would go into the rapid shutdown devices or your optimizers. And so you can do that. You can accomplish that. You'll do that by using the pins, the pin out here on the communications wiring. They are labeled on the board, and we'll get into that a little bit more. But if you're using a 2-wire start functionality to allow the inverter to automatically start up and shut down your generator as needed, then you would use pins 4 and 5. And we're showing that with our Power Protect units that are there as well. So the pin out here for the accessories, there are a number of things to point out, maybe just highlight a couple of them. So if you're wiring in the CTs, you would use pins 3 to 6. If you have an external battery temperature sensor, now our communicating batteries will communicate that information directly to the Sol-Ark, but if you had an external sensor, you can use that through ports 1 and 2. CTs are useful if you're trying to do peak shaving so that you're not pulling more than a certain amount from the grid, or if you're just really trying to zero out the grid, essentially off-gridding yourself by using CTs to monitor how much you're bringing in from the grid and getting the inverter to output that same amount so that essentially you're not pulling anything from the grid. The Gen Start relay, that's pins 7 and 8 on the Sol-Ark. And then the E-stop button, which is also important. That is a normally open dry contact. So you want to get a switch that's normally open. And then when you close it, it completes the circuit and does an E-stop. So that's the BB on the right side of the pinouts. So battery programming and setup. Any questions that I should pause for, Daniel, before we jump into a new topic?
Yeah, there's a couple good ones. Mike is asking, you mentioned the temperature sensors. He's asking, can you set the temperature compensation to 0 as though you're not going to take any actions based on the temperature sensor, just to be able to monitor the lithium ion battery temperature?
That's a good question. And there's very little change in lithium iron phosphate batteries with temperature. So if I were to show you a graph of what the resting voltage looks like as a function of temperature, there's almost no change. That temperature compensation is mostly for lead acids. And I think the answer is yes, although I'd have to defer to Sol-Ark to make sure. But I believe that the temperature compensation can be set to 0. And I will point out, though, if you're using an external temperature monitor, you're not necessarily getting the temperature of the cell pack, which is what you're probably more interested in. And so if you really want to monitor that using the communicating batteries, you'll have that. But if you're using non-communicating batteries and you want to monitor their external, their wall temperature, Daniel, what do we normally do when we're trying to use an external temperature sensor, get our battery temperature? Where do we put that?
We try to embed them between two batteries to
Yep.
replicate the cell temperature as close as possible. Mike
Yeah,
actually
exactly.
asked another question, and this could really get us down a rabbit hole, but I think it's a great one. I know we're coming up on the end of the hour, but Mike also asked, if batteries are kept close to float voltage, does that reduce their life? And I'm gonna ask Nathan, does that answer change whether we're talking about lithium ion or lead acid?
So this is a great question. It depends on what that float voltage is, right? So we recommend a float voltage of 54. And if we keep our batteries floating at 54, I don't believe it has any effect on the lifetime. I haven't done long-term experiments, but SimpliPhi has. And we've been around, for a long time kind of perfecting our float voltage. That's why you might notice that our float voltage is a little bit lower than some others. With lithium ion batteries, NMC style lithium ion batteries, the answer is it absolutely does. And that's why with NMC batteries, you're typically encouraged to only charge them up to 90% capacity unless you need that full capacity. With lead acids, I don't know on that side of things. And so I would have to say, I'm sorry, I don't have more information. This is a good question. I appreciate it. In the interest of time, I think I've got about 8 minutes left. I want to jump through this battery programming just so that you have record of it. It's a fairly easy thing to do on the Sol-Ark. So first off, the GUI on the front of the graphical user face on the front of the Sol-Ark it's all the same. It's the same with a 12, or if you've done an 8 or a 12, it's basically the same. You've got a touchscreen display, and up in the top right corner, you have a settings profile. So if you click that settings, what you'll see is the screen on the right side of the screen. You'll see the screen that's being displayed on the right side here. And if you click battery setup, so under basic setup, you can tick off some different things. One of the things that you'll want to make sure you tick off on that basic setup is to have the display turn off. Otherwise, you don't have a warranty on the longevity of that screen. Screens burn out with time. So under battery setup, you'll come in and you have different options for the battery. So under the basic setup here on the left side of the screen, the battery setup, you can either use a battery voltage or a battery percent to create your settings for batteries. And I was told in one of these previous trainings that if you highlight the BMS feature, because you have communicating batteries, so that's what you would do for communicating batteries, that this will default to a percentage, I believe. Under the battery capacity, of course, on the left side of your screen, you're going to input the total number of amp hours that your battery has. You would get that from your manufacturer. In our case, we provide that to you. And the maximum charge and discharge, these are global settings where you can break this down into different sources later, but for right now, these are global settings on the left side of your screen. You see the temperature compensation coefficient on the left side of the screen is set to 0. So I think that answers your question. The answer is you can absolutely do that. On the right side of the screen, when we get into the charge, so we've switched from battery to charge and discharge now. If we had selected voltage, then we would be able to program those values in for a voltage. On the you have a generator settings there as well as grid settings. And so we're giving our maximum values or our values for charging from the grid there. If you had checked the generator box, you'd be able to provide those values for generator when the grid is unavailable. For our batteries, the float voltage is 54. The absorption voltage is 56. That's the voltage you get to when you're doing that constant current charge cycle at the beginning. And then our equalization, we're going to set that to 0. That equalization there is for burning off sulfur for lead acid batteries. You never want to use that with lithium batteries. Let's jump into the discharge cycle. So the battery resistance, that's for our batteries, this battery resistance has to do with, there's a drop in the voltage output of a battery that's depends on loads. So if you notice your batteries, for instance, your battery bank getting below your LBCO, where the inverter is still running, it's because there's some compensation with this setting. So if you can't get below your LBCO when you have large loads, or if your inverter is shutting off a little too early, make sure you have the appropriate battery resistance programmed in under this tab. The shutdown voltage there, that shutdown voltage is when that inverter will do a shutdown. That will shut off the batteries and switch over to different sources. The low battery voltage is really just a voltage there that triggers, or a percentage that triggers the warning symbol. And then the restart is when you've gone past the low battery cutout so that the inverter is shut off battery. It's going to initiate a new charge cycle, and it won't start discharging the batteries again until you hit that restart voltage. The battery empty voltage that you see on the screen, that battery empty voltage is there to protect the inverter from basically having the battery shut itself down at the BMS, the battery management system within the battery. So I know I'm pretty short on time. I'm going to keep moving, but again, make sure you get that battery resistance right. And I've shown you on the screen what values to put in for the battery resistance. On the grid parameters, when you're setting up the grid parameters of the Sol-Ark 15k, you've got a lot of options, and a popular option for setup is what I've enabled on the right. So there's different tick boxes that you see there for the grid setup, allow you to do different things. So for instance, time of use, you can tell the inverter how much power you want to discharge. You can limit how much you discharge at different times of the day. So if you want to use the majority of your battery power when grid power is expensive, you can save some of that power and set that output limit for different times of the day, which you set up on the right side of the screen there. The grid sell is how much you're selling that solar or potentially battery, if you want to, back to the grid at different, and you can set up times to do that as well. So the grid cell here, we're limiting to 8,000 watts. And then if you do limited power to home, that's where you can use those CT sensors and limit the amount that you're pulling from the grid. Under grid input, so most of the installs here in the US are going to be the 120/240 split phase. 220 single phase is going to be in other parts of the world where you would actually not be using that neutral wire. You just have a single live wire as opposed to two live wires, L1 and L2. And then of course I mentioned if you've got if you want to do 3-phase, a single inverter can supply 2 of the 3 phases. 2 inverters can apply all 3 phases, but you won't have balanced. And then if you want to do a balanced 3-phase output, you can do 3, 6, 9, 12 inverters for that. Your grid parameters there, these are the parameters that you're going to be high and low, so you'll accept that grid input under these parameters. If you want to have a wider tolerance, you can add it there. So if you live in a location where you have challenging grid conditions, you can modify that there. And then I'm showing on the right side of the screen, you would need to set up masters and slaves for each phase. If you're doing parallel inverters with 3-phase, we'll have more on that in a future high voltage 3-phase, a future 3-phase training with parallel Sol-Arks that'll come up. Here's another example of a nice install showing a couple of parallel systems there with 15 of our 5 batteries. I did want to talk, but I don't think I have time to talk about the temperature protections built into our BMS system. So we do a lot here to make sure that we can operate over a wide temperature range with our batteries. And if you're interested in this, stay tuned for one of our our trainings on batteries in harsh environments. Monitoring, I'm again going to skip through this, but I really like the PV Pro app and the amount of monitoring you can get from the Sol-Ark. So you can monitor things like temperature. You can monitor the battery. It goes positive and negative depending whether it's pulling power out or putting power into the battery, etc. You can really customize these features in what you're monitoring. Sorry for jumping through fast on the end here. I want to highlight one last thing in our last minute, and then I'm happy to stay over just a few minutes here for questions. So we do have an IQ installer program where right now we're offering $1,000 cash back for your first SimpliPhi/Sol-Ark install. And so if you're doing an ESS install, you can get that $1,000 for your first one, as well as $100 back per battery if you join our Elite Installer program. If you're interested in that, please use this link when I send the slides out. So this is a link about those rebates that you can get. If you have time, give us some feedback on this training, how we can make it better. I know we're short on time for it, so I think in the future we'll try to cut out some of the early slides. And here we are at the very end. If you have more questions, go ahead and throw them in the Q&A, and Daniel, you can share them with me. But I want to point out, for those of you here for the continuing education credits, our email is there, energystoragetraining@basco.com. So send us an email, tell us how your name should appear on your certificate, and we'll get those certificates issued. Thank you, everyone. Daniel, any questions we can answer here?
Well, please put any questions that anybody has. We do have one that came in a little bit earlier, and it goes back to the topic of a Sol-Ark and when you have AC coupled and generators combined. And I think that was a great, some great conversation we had earlier. And Mike is asking, you know, I did not think you could AC couple through the loads panel and have a generator connected, right or not? And I think maybe we'd expand as to where would the generator be connected. So maybe just kind of rehash what kind of challenges and what do we need to do if we have
yes
both?
and no. If we AC couple through the loads port and have a generator connected, we would have to have a lockout module that locks the AC coupled solar out when the generator's running. Otherwise, the AC coupled solar, basically the gen port is connected to the load port when that generator is running, right? So you can do it, but you need a lockout module to prevent the AC coupled solar from coming in. So that's a great question. I'd love to get into more details with you on that, Mike. And so feel free to engage us, and we can talk through how we might do that. We can engage Sol-Ark too. We have an active relationship with them, and I can get Dylan on the phone and we can go through it.
That's all we had. Thank you, Nathan.
Thank you, everyone. We really appreciate your time and attention here, and you'll get these slides from me as well as your NAPCEP credits as you need them in an email that'll be coming. I normally wait till the next day to send it, so all of you can get your requests in. Thank you, everyone.